This problem is problem number 68 from the first problem set. And the first thing I'm going to do is just read through it and figure out what kind of information I have. So I see that I have 20 milliliters of potassium carbonate, and I'm adding that solution to 30 milliliters of, it looks like barium nitrate, and I'm also given molarities of these. The potassium carbonate is 0.2 molar, and the barium nitrate is 0.4 molar. And it tells me that barium carbonate precipitates. So I know if I'm going to precipitate something, I need a chemical equation because I have a reaction. So I'm going to do that right now. Potassium carbonate plus barium nitrate. Well, looking at this, I have two compounds, so I know that it's going to be a double replacement reaction. So the outsides come together, potassium and nitrate. So just as a side note, potassium is a +1 and nitrate is a -1. So together they make KNO3. You don't keep these little 2's. That has to do with the charges, but I'm going to use the coefficients to balance the equation later. And then the inside ones, barium and carbonate. Now I know barium is a +2 and carbonate is a -2. So together they would just make BaCO3. That is going to be my precipitate, so I know that it's solid. Looking at this, my issue is with the K's and the NO3's. So if I put a 2 here, it's resolved. And then the question says the concentration of barium ion, Ba2+ in solution after the reaction. So I know all of this barium, this is the only place barium comes from, is either going to turn into barium carbonate or it's going to be left over as Ba2+ in the solution. So whatever doesn't turn into barium carbonate is going to be left over as Ba2+. So now let's look at what I have. First, I'm going to figure out how much barium nitrate I start with, because that will tell me how much barium I start with. If I have 30 milliliters, I know that there's 1,000 milliliters in 1 liter, so that would be 0.030 liters, and I have 0.4 molar. So if I want to find the moles of BaNO3, it's molarity times volume, so 0.4 molar times 0.03 liters. And if you put that in your calculator, which I'm about to do now, I get 0.012 moles of BaNO3. Now if I look at that, the number of moles of BaNO3 is also going to equal my number of moles of Ba. Because if I gave you 1 barium nitrate, you would have 1 barium in there, 2 nitrates. If I gave you 2 barium nitrates, you'd have 2 bariums and 4 nitrates. So this is also going to equal 0.12 moles of barium. So this is how much Ba2+ I start with. Now let's figure out how much Ba goes into the barium carbonate when it actually reacts. So this is a limiting reactant problem essentially. I have 2 different things. Now I've got my 20 milliliters, which I can convert to liters, 0.02 liters of potassium carbonate times the molarity and this will tell me how many moles of potassium carbonate I have. So I get 0.004 moles of potassium carbonate. And if I want to figure out how many moles of barium carbonate, I simply do my little T-chart And I know from my balanced equation that I have 1 mole of potassium carbonate for every 1 mole of barium carbonate. So that gives me 0.004 moles of barium carbonate. Now I'm going to do the same thing with barium nitrate and see how much barium carbonate I can make to figure out which one's my limiting reactant. Now I already found out how many moles of barium nitrate there were up here, so I have 0.012 moles of barium nitrate. That was just my first step here. And if I do my little T-chart, in my balanced equation, there's 1 mole of barium nitrate for every 1 mole of barium carbonate. So that means I make 0.012 moles of barium carbonate. Looking at this, I know my limiting reactant is the K2CO3 because it makes less barium carbonate. So now that told me that this is how much barium carbonate I make. This many moles of barium are in barium carbonate, but I know I initially started with this many moles of barium. So if I simply subtract, that will tell me how much barium is in solution. So I'm going to slip an extra piece of paper in here. And if I continue, so I know I have the moles of Ba2 plus left over is the moles of Ba2 plus that I start with minus the moles of Ba2 plus in the barium carbonate. So basically, barium can be in 2 spots. It's either in barium carbonate or in the Ba2 plus. And I've got to figure out what's left over. So I know I started, if I peek back, I started with 0.012 moles of barium. And then I used up 0.004 moles. So when I do the math out, I get 0.008 moles of Ba2 plus left. And it asks for concentration, which I measure concentration in molarity. So if I find the molarity of Ba2 plus, I need to do the moles, 0.008 moles of barium ion, divided by the liters of solution. Well, I know I had 0.03 liters plus 0.02 liters, so that would be 0.05 liters, also known as 50 milliliters. Solution. And so when I do this math out, I get 0.160 molar Ba2 plus. So just to recap, in my initial equation, I found out that I precipitated barium carbonate. I know that the K2CO3 is the limiting reactant, which means that the barium nitrate is the excess reactant. There's going to be some extra barium there. So the extra barium is going to be Ba2 plus in solution. So the first thing I did was find out how much barium I started with. That came from all the barium nitrate. That concentration was 0.012. Then I found out how much barium carbonate I made. I found that to be 0.004 moles. Then I realized that I needed to figure out how much was left over by subtracting what was in the precipitate from how much I started with, and that will tell me how much is just hanging out in solution. Found the moles, divided by the total liters to find the molarity, so this is my final answer.